those out in your classroom. You have a trip, electricity trip, anything like that, please text me on my personal cell phone so I can come look at it. They are working on.
Oh, good thing we're recording the lesson.
And heaters and things like that. So please just stay flexible in this last period of the day. But if you have an electricity trip, please let us know here in the office. Text me or call the front office. Thank you.
All right. Here we go. You guys ready? Do you guys want to take 30 seconds to see if you guys can do question 16? You actually already did it previously in different notes, but do you want to try again or no? All right, take 30 seconds, guys. Yeah, don't look up. I'll say the same thing I said when we first did this question. This type of questions are what's separating the 5s from the 4s. You can see that 74% of the 5s are getting this question correct, and 46% of the 4s are getting this correct. So a big drop. Yes, miss. I still haven't printed them. You didn't say after school, so you couldn't remind me. Okay. All right. I finally uploaded those notes, though. So I'll save for a little bit, and we'll get them printed. Okay. All right. So inverses, guys. Traditionally, inverses tend to be the hardest, supposedly. Look at, these are one of the two lowest questions that people got correct. Look at question 26 and 28. Only 25% of the population got question 26 correct, and only 14% of the population got question 28 correct. As a matter of fact, even the 5s are struggling with this. Look at the percentage of 5s that got it correct. 38% of the 5s got question 28 correct, which I find ridiculous because question 28 can be answered in like 5 seconds. You're going to see it's not bad. I think what's happening is maybe teachers aren't going over these questions, or who knows, maybe they were tired because in that year that question was the last question on the exam. So before we do question 26 and 28, we don't know inverses yet, so we can't answer them. So why did I put them in the front? Because I wanted you guys to see the data. It's not bad. You'll see. Go to the next page. We're going to talk about algebra. Let's talk about what we know about inverses. What do you know about inverses? Okay, yeah, you can say they undo each other. You get perfect. They reflect across. Yeah, you're right. They reflect across the y equals x. So I'm just drawing some random curve here. I'm just drawing an f of x. And the inverse of that curve is going to look like that. And I'm going to call that the inverse. If I have a point, let's see, if I have this point and I'm going to call that a comma b, then I have a point on the inverse graph, and that's going to be b comma a. If I have a tangent line, let me draw the tangent line with this. It's not the most perfect tangent line, but that's fine. Then I'm going to have It's not the most perfect tangent line, but that's fine there. Those are tangent lines. So we know, so let's see, what do we know? We know that if I have a point AB and I find the inverse of that point, now my point is BA. Let's see, what else do we know? We know that if we have a slope, change in y over change in x, and I find the inverse, my slope is now change in x over change in y. I want you to observe something, guys. Don't say opposite reciprocal. If I have a linear line, so I'm just going to do a hypothetical situation. If y equals 3x plus 2, just something random, and I told you that I want the inverse of that line, how would I do it? Well, if I want the inverse, I flip the x and the y, so I say x equals 3y plus 2, and then I solve for y, right? So I guess I'm going to move that 2 to the other side, and I'm going to write 3y first equals x minus 2, and then divide everything by what? 3. I want you to recognize y equals 1/3 x minus 2/3. So here, I want you to recognize that my slope is 1/3, and the slope of the original was 3. Do you guys see that? This follows with this. Look, my slope was y over x, or change in y over change in x, and now my slope is change in x over change in y. There's a word for that. It starts with the letter R. The reciprocal, just reciprocal. Do you guys see that? So it works the same way. So it says, so calculus involved, think about it. What if we want the derivative of the inverse function? So if I have a grid, so here's my grid, and I'm going to go slow, and I hope that it makes sense. I'm going to try my hardest to make sure that you guys understand the concept. Can you be a robot with this? I guess you can, but try not to because you'll forget. I'm going to try to make you understand the concept of this. So here's this line, the y equals x. And then what's the easiest curve? An exponential and a log. Let me write it better. I'm trying to do an exponential function here. So here's my exponential. Here's your log. And if I know that this point here is a comma b, okay, follow along, guys, follow along. And I know, so then that means that this point over here on the inverse one is b comma a. Are we still okay? So if I know that I'm going to call this f, so let me take it sky blue, f, this is f of x. So then if I know f prime of a, and then I'm going to point and write a letter, I'm going to say it's some slope c. Are we still okay? Nothing crazy, right? So then do I know, let me go for purple, do I know the inverse of this? That's f to the negative 1 means inverse. I'm going to put parentheses on this. I'm going to put a prime, and I'm going to put not the letter a, but the letter b. Do I know the derivative of the inverse at b? No. What did we say over here when we did 1 over c? Good job. Because that's all we did, right? We just did the reciprocal. And instead of writing it 1 over c, here's what I'm going to write. Notice that I'm not writing 1 over c yet. I'm writing 1 over f prime of a. Are we okay? And then 1 over f prime of a, well, that is 1 over c. Yay or nay? Okay, I think we're good. I think we're golden, like Harry Styles says. I think we're golden. I think we might have just done, we wanted just one gold right now. All right. Here is what this illustration is trying to prove. All right, guys, focus, because this is tough. This is only 14%. So focus on this, please. I need your A game. So here's what this illustration is trying to prove. It's trying to prove I have a tangent, and I have an inverse, and I have another tangent, and it's trying to say that this tangent is just a reciprocal of whatever that slope is. And then it has this, that is that. So no one's freaking out, right, with the notation? All right, but let's see if we got it right. I know it says to go to question 28, but I wanna give you guys practice first to see if we can get question 28 correct. If we can get a question 28 correct, you should celebrate and go have dinner tonight. All right. Question 15. This question. Suppose that f has an inverse, and I have a coordinate. This is like an a, and this is like a b, or -7, 2. And then tell me the derivative. The derivative at -7 is 4/5. They want to know what is the slope of the inverse at 2. Well, that 2 was a y on the original. Do you guys see that? So all I do is I find f prime of 7, and I found it. F prime of 7 is 4/5. Now what do I do to that 4/5? I just, or not inverse, just take the reciprocal. So here's my notation. This evaluated at 2 is nothing more than 1 over f prime of 7. That's all it means. And you already told me that f prime of 7 is 4/5. So 1 over 4/5, that just means take the reciprocal. So 5 over 4. Does that make sense? Okay, we're going to do one more together, and then we're going to see if you can get question 28 correct. Suppose that f of x equals 2x plus 6 squared of x and is differentiable and has the inverse for x greater than 0. So they're telling you it has an inverse. And they're being nice. They don't have to tell you this, guys, but they're being nice. F of 4 equals 20. So that means if I plug in a 4 in here, I get a 20. Let's see, 2 times 4, that's 8. Plus 6 times the square root of 4. Well, 6 times the square root of 4, the square root of 4 is 2. 6 times 2 is 12, and 12 plus 8 is, in fact, 20. Are we okay? Yeah, 12 plus... Okay, so here we go. They want the derivative of the inverse at 20. Are you going to try and get the inverse function? No. I mean, you can, but it would be really hard, especially when you got an x and the square root of x. So don't even try that. So the next step, so I'm going to write f of -1, the derivative of that evaluated at 20. I don't know why I wrote the 0 like that, sorry, is nothing more than 1 over f prime evaluated at 4. I can find the derivative pretty easy of that function, no? I can find it pretty quick. F prime of x is equal to, the derivative of 2x is 2. This is 6x to the half. So plus half of 6 is 3. X to the negative half. See? I'm going to rewrite it. 2 plus 3 over square root of x. That's f prime of x. And here I am plugging in a 4. F of 4 equals 2 plus 3 over square root of 4. What's the square root of 4? So 2 plus 3 over 2. Common denominator, turn that 2 into 4 over 2. What's 4 plus 3? So what's 7 over 2? So where are you? Oh, yeah. Yeah. So f prime of 4 is 7 over 2. But I don't want f prime of 4. I want my inverse. So I just take the reciprocal of 7 over 2, which is 2/7. So the answer is A. All right. Go to the first page. And it's okay if you get it wrong, guys. Question 28. Before we start this one, remember, they had the whole year to do this. So don't feel bad if you don't get it right. Let's see if you can do question 28, which that year supposedly was the hardest question. Go for it. Take 30 seconds. Let's try it. Read it. Oh, you did it? Okay, sorry. Too fast. All right, I'm going to read it, guys. I'm going to start it. It says, let f be a differentiable function such that f of 3 equals 15, f of 6 equals 3. So these are just points, right? 3 comma 15, 6 comma 3. And here's my slope at 3, and here's my slope at 6. The function g is differentiable, and g of x equals f of negative 1 of x. That means they're letting you know that f and g are inverses of each other. They're letting you know. What is the value of g prime of 3? Okay, here's my little formula. Ready? G prime of 3, remember, g and f are inverses of each other, is nothing more than 1 over f prime of which one? Of 6, guys. Because you just told me right here when we did this one. Look, that was a b, and that doesn't say b. Guys, if I call this inverse g, if I call that a g of x, then all this would change is g prime of x evaluate, well, actually, I got to say a letter. So g prime of b, so let me write it. G prime of b is equal to 1 over f prime of a, if I were to call that g. So this, f and g are inverses of each other. If you don't like g, then just say f of negative 1 to the derivative at 3. It has to be the inverse, guys. That 3 was a y on the original, so I'm looking for this one right here. I'm looking for that one, so I'm looking at that one, f prime of 6. So g prime of 3 is 1 over negative 2, so my slope is negative 1/2. This is as hard as derivatives get for inverse function. If you can just find the inverse function, well, then just find the inverse function and take a derivative. But they're going to make it where you're not going to be able to find the inverse. So you have to do it like this. Am I making myself clear, guys, or no? Okay, tell me, Flores. Tell me. Dime.
I don't even know where it starts.
Okay. Remember we did a linear line? And I told you to find the inverse of that linear line? I want you to notice that linear lines are simple because it doesn't matter where you're at, your slope's always that constant. Look, I found my constant to be a 3, right? I found my slope to be a 3, and then I just took the reciprocal of it, and that was my inverse, 1/3. So I'm doing the same thing. If I have a slope right here of this tangent, so I'm going to pretend that tangent has a slope of 2. If this has a slope of 2, f prime of a equals 2, then I know what this one is. What's the slope of this one? Well, it can't be 2. It has to be 1/2. So then that means g prime of b equals 1/2, the reciprocal. Because look, remember I told you that the slope of your inverse is just a reciprocal? We know that from algebra 2. So it's the same logic, miss. It's the same logic. I have a point. That point AB is the point BA. So I can't say, if I say f prime of a, I can't go, and I call this one g, I can't go g prime of a. I got to go g prime of b.
So I guess what I'm lost is how do you actually know? Like, how does that apply to this equation?
It's the same. How does this apply to this? They're telling me that these are inverses. Look, that 315 and that 6,3 are on f. So what's on g? If I know this is f and and g are inverses, that okay. We're gonna talk and write on here. If I know this guy, so I'm just gonna write a whole bunch of shenanigans here. If I know that f of 3 equals 15, and I know that f of 6 equals 3, and remember f and g are inverses. That means I know. What do I know, Travis? What do we know? That g of 15 has to equal 3, and that g of 3 has to equal 6. Right? If I know my slope at f of 3, so I'm going to write it right here. If I know that f prime of 3 equals negative 8, then that means that I know g prime of, g prime of 15 equals negative 1/8. I took a reciprocal. Because that point, 315, what's the point on g? 15,3. This point, 6,3, what is it on g? 3,6. So I'm going to do another one. I'll put it right here. G prime, or let's do f. Let's do f. F prime of 6 equals 3. So I know G prime of 3 equals, do they give it to me? They don't give it to me. Oh, yeah. They don't give it to me because that's what I'm trying to find. G prime of 3 is the reciprocal evaluated at 6. Okay, I'm going to make up a problem. I'm going to make up a problem. Negative half. Yeah, because I took the reciprocal of negative 2. I'm going to make up a problem. Okay, write this down. Write this down, guys. F and G are inverses. Write this down. Put it right down somewhere. So I'm going to give you this. I'm going to give you, let's see, F of 2 equals 5. F of 3 equals 12. I'm just making those numbers up. Okay, we ready? So I'm going to make up some more numbers. I'm going to give you derivatives for both of them. F prime of 2 equals, I feel like, negative 7. And F prime of 3 equals, and I feel like, negative 9. I just feel like those numbers. Okay, ready? Are F and G inverses? Okay, I want, let's see if you guys, I want G prime of 5, question mark, and I want G prime of 12, question mark. I can get those numbers. G prime of 5 is 1 over F prime of 2. Why? Because 5 was a Y value on the F. So this one is 1/5. Yes or no? The reciprocal. Oh yeah, my bad. I was not looking at the negative 1/7. Negative 1/7. Sorry. All right. G prime of 12 is 1 over F prime of 3. Do I know what F prime of 3 is? So 1, negative 1/9. Okay. Now that we know this, did that make sense to you or no? Did I lose you with my little accident in the beginning?
I'm just trying to process it on my own, of course. You got it flipped to get this flip, so I'll be fine.
All right, I'm gonna go back.
Oh, you were
Okay, ready, Flores?
I'll be fine.
Yeah, check it out. This 3, G prime of 3, that 3 was a Y on the original, on the F. So I look for where I have this point, F of 6 equals 3. See? So then that means I need to find F prime of 6. Well, F prime of 6, they tell me is negative 2. So G prime of 3 is 1 over F prime of 6. So 1 over negative 2, or you could just say negative 1/2. Cool? Okay. And that's because, so let me see if I can try and explain it with the visual here. My mandatory daily hit. Hopefully God doesn't punish me. Okay.
I'll laugh like the lights go out.
Yeah. No. It's not lights are not gonna go out. Okay. All right, guys, real quick. I need your A game. Pretend this point right there was 2-4. And that's all I know. On this point that point is 2-4. Yes or no? Yes. If I know the slope of, remember, and this has an inverse. So F and G, this graph here and this graph here, sky blue and light purple are inverses of each other. Yeah?
Yep.
If I know that at 2, 4 that this slope is 3, then I know my slope of the inverse, not at 2, 4, but at 4, 2. Because they're inverses of each other. So if I know that this one's at, my slope is 3, then that means this slope has to be 1/3. So if I call this f prime of, what did I say, 2, 4? If I call that f prime of 2 equals 3, then I have to call that g prime of 4 equals 1/3.
Everything.
Does that make sense?
Yeah.
Yeah, see, because guys, they're inverses of each other. And the properties of inverses, changing y over changing x over changing y.
Because
My xy now turns to yx.
Because,
Boom.
like, between inverses, x becomes y, y becomes x.
Yes. Boom, 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 boom. Bam. All right. You didn't see that one coming. Yeah. It would have been funny if I would have fallen and hit. Like, no. Okay. Nah, that would not have been funny because I don't want to go to hell, guys. I want to go to heaven. Okay. All right.
Tom, you would not go.
All right. All right, guys. That's as hard as it gets. That's as hard as it gets. These inverse trig, now I don't know why. As you can see here, inverse trig is still a low percentage, but you're going to see inverse trig is a lot easier than just regular inverses. A lot easier. So we're going to do one. We're going to derive one like we always do. And then I'm going to tell you to memorize them unless you want to do this all the time, but here we go. So we're going to do an informal proof of taking a derivative. You guys ready? We do not know what this derivative is because we don't know it. We haven't done it yet. But we know this much. We know that this means sine y equals x. Yes or no? Yes. And we know how to take implicit derivatives. That's what it means. Arc sine, y equals arc sine of x. That's what that statement means. Cool or not cool? All right, let's take a derivative. I'm taking the derivative with respect to x. So what's the derivative of sine y? Cosine, and I got to keep that argument. Cosine of y, and then what do I put on the outside of that? dy dx, I'm taking the derivative with respect to x, equals what's the derivative of x? 1. I want to get dy dx by itself, because that's what I'm looking for. I'm looking for a derivative. So I got to divide by cosine y. dy dx equals 1 over cosine y. Catch up to here. This is a perfectly acceptable answer if I did not care about what letter I wanted. But if I tell you I must have the argument be an x, I must, then here's what we're going to do. On the side, here comes pre-cal. On the side, I'm going to write cosine squared y plus sine squared y equals, yeah, what does that equal? 1. I'm going to get cosine y by itself. You guys ready? I'm going to move this to the right. So I'm going to write cosine squared y equals 1 minus sine squared y. Catch up to there. Are we still okay? And then I'm going to take a what? So because I want to substitute cosine y. Take a square root, take a square root. Cosine y equals the square root of 1 minus sine squared y. Are we still all right? And I know what you're thinking. You're like, Chav, how does that replace it? I still see a y. Well, you'll see right now. 1 over the square root of 1 minus sine squared y, which just means, and I know that I'm being really redundant here, but I want to make sure that you guys understand. It means this. Are we still okay? Notice that the very first line, way up here, it says that sine y equals what? X. So I can just substitute, and I can rewrite it, and I can say, therefore, the derivative is nothing more than 1 over the square root of 1 minus x squared. And there's my derivative of arc sine. Are you going to do this all the time? Derive it from scratch like this? No, you're just going to memorize it. It's not hard to memorize. Arc sine and arc cosine look the same, but remember anything that starts with the letter C has a what in the front? Negative. So arc cosine is the same derivative with a negative in the front. Cool or not cool? So let's do chain rule. I'm going to go, oh, yeah, it's not in there. So let me do chain rule. So hence, I'm going to write it like this. d dx, parenthesis, arc sine of u. That way you guys can know what's up. is 1 over square root 1 minus parenthesis u, close it, squared, and then on the side, chain rule, du dx. Yeah, don't worry, we're going to practice right now. All right. And I would probably, if you like to have like stuff rectangled in, then I would rectangle in that note right there. All right, here we go. I'm going to go slow. Ready? My u, did you say no?
Yes.
Oh, did you say yes? You are ready? Oh, which one is it? No or yes? Yeah, go. This is pretty easy, so you can go. All right, from here, this is easy. This is the easy part, so you won't have any issues. All right, here we go. Look how easy this is. What's your u? X, not just x squared. So I'm just following this right here, guys. 1 over, this has to take the derivative, square root 1 minus parenthesis, my u is x squared, so I put x squared, close it, and I put another square on it. Am I done? No. Chain rule, times the derivative of your u. What is the derivative of x squared? 2x. Make it nice and pretty. So 2x over square root of 1 minus x to the 4th. There's my derivative. ¿Cómo te sientes? How do you sit? Yeah, I know, that's lame. I won't say that again. Yeah, because ¿cómo te sientes could be how's your feelings or how do you sit, depending on how you, okay, yeah. All right, tell me, dime. Are we okay? Okay, go to the next one. I give you all the rules. Relax. Number 19 is the one that we just learned. Look at number 20. Arc cosine, what's the derivative? It just has a what in front? Negative. Look how easy they are to learn. Arc tan is 1 over 1 plus x squared. Sometimes they call it x squared plus 1. Remember, that's the one that we did in the circuit that I told you guys didn't know yet, and I just gave it to you. So there it is. Look at arc cotan. It's the same as arc tan. The only difference is what's in the front? Negative. And then arc secant and arc cosecant are the same, but look at arc cosecant. It has a C. So what do they have in the front? Negative. Which ones are the most common? We're not teaching you the test, but the most common is arc sine, arc tan, and every now and then arc cosine will come out. I have yet to see if these come out. I have only seen them in the calculator section, and you have a calculator, you can just tell the calculator to give you the derivative at a point. But arc sine and arc tan are the most common. Memorize those. Cool or not cool? And then it says in the bottom, what about chain rule? What if chain rule happens? Okay, sorry for the voice. Chain rule. So here it is. I'm just going to do a few. Number 21. So ddx of arc tan. And I'm going to put u inside like that so you can do chain rule. 1 over 1 plus parenthesis u, close it, squared, times du dx. That's chain rule. See? Which one else do you want me to use chain rule for? It doesn't matter which one, guys. We already did arc sine with chain rule. Do you want me to do arc secant with chain rule? Yeah. All right, ddx, arc secant of u, close, equals 1 over u, square root, parenthesis, u, close it, squared, minus 1, times du dx. If you feel compelled, write them all in there. For those that have good notes, if you want to know what Mazuka did, Isabella Mazuka, who went to MIT, she did the U sub for all, like she did chain rule for all of them because she just wanted to do all of them on the side. So she did them all, and they're all nice and neat, and that's what she took with her to MIT. Cool or not cool? Sorry, Mazuka, if you're listening. Hello. Okay. All right, let's go to the next one. And now it's just application, guys. Oh, you know what? Let's try. Do you think we should try? Yeah, let's do it. Go to page number 1. No. I think you're gonna be able to do it. I really do. Take 1 minute. See if you can do question 26. You can use your formula that you just learned.
Oh, Lord.
No calculator. Oh, no. All right, I'm gonna go ahead and start, and let's see if you guys got it. What is the slope of the line tangent to the curve arctan 4x at the point where x equals 1/4? If they want the slope, I have to take a what? Derivative. Here's my derivative. Y prime equals, what's the derivative of arctan? 1 over 1 plus u squared. What's my u? So I'm going to put 4x in there, close it, put a square on it. Am I done? Chain rule times the derivative of your argument. What's the derivative of 4x? 4. If you can do that, you're probably gonna get it right. All right, now we're just gonna plug in. What am I gonna plug in for x? 1/4. So here we go. Oh man. Okay, here we go. Y prime at 1/4 equals 1 over 1 plus parenthesis 4 times 1/4. We'll figure out what that is in a little bit. Square it times 4. What's 4 times 1/4? 1. What's 1 plus 1? 2. So I have a 4 in the numerator and 1 plus 1, which is 2. And what's 4 divided by 2? 2. So the answer is? If you did that, and look, we're just getting started. And you got it, you're already with the 5, 53%. Cool or not cool? All right. Hey, it's okay. If you got it wrong, it's fine, guys. We're just getting started. Go to example 2. Maybe we should have done example 2 before we did example 1. Before we did that one. That's fine. All right. A particle moves along the x-axis of its position at any time t greater than or equal to 0 is given by arctan of square root of t. What is the velocity of the particle when t equals 16? How do I get velocity from position? The derivative. Let's take a derivative. Here we go. V of t equals, what's the derivative of arctan? 1 over 1 plus square root of t squared. Am I done? No. Chain rule. Yes.
Is the velocity of position?
Yes. What's the derivative of the square root of t? Remember, that's the same thing as t to the half. 1/2 t to the negative 1/2. If you can get that much done, you're winning. So here we go. Yes. V of t equals, I'm just going to do this first. 1 over 1 plus t, the square root of t squared is t, times, and I'm going to write it 1 over 2 square root of t. So you don't get confused, I would write it like that. And now what am I going to plug in? The 16. V of 16 equals 1 over 16 plus 1? 17 times 1 over 2 square root of 17. Oh, 16. My bad. 1 plus 16 is 17. All right, so let's see what that is. 1 in the top. Square root of 16 is 4. 4 times 2 is 8. And I don't know what 17 times 8 is. I'm going to leave it like that. Whatever 17 times 8 is, I don't know. What is it? 17 times 8? Does someone know what 17 times 8 is?
I love it.
136? What is it?
136.
136. There. Oh, yeah. Okay. All right. Go to the next one, guys. Let me check let me check real quick that I took attendance before they call me.
You did like real?
Are you doing attendance?
Yeah.
How was that? What's the ridiculous class? Oh, is that what you're in here? What is that what you're in here? Is that what you're doing your time?
All state literally
Okay. Here we go, guys. Derivative. All right, guys. Focus. We're almost done. Derivative of arcsecant of 5x to the fourth. Look at your notes. The derivative of arcsecant is okay, 1 over the argument, which is 5x to the fourth, square root of 5x to the fourth, close it, put a what on it? Squared, plus or minus 1? Minus 1 times, am I done? Times the derivative of 5x to the fourth, which is 20x cubed. So here it is. So 20x cubed over, and I guess I'm just going to write it pretty here, 5x to the fourth square root of 25x to the eighth minus 1. And you can leave it like that. I think that looks okay.
I do. I'm just no, they're not. It's like
I hate art.
All right. No, don't say that. Don't say that. All right. Sorry, miss. Find an equation for the line tangent to the graph of y equals arc cotangent of x at x equals -1. So the first thing I need two things. What and what? Point and slope. So I have -1, comma. Where is cotangent -1? In quadrant 2 and in quadrant 4. What's the answer in quadrant 2? No, power 4. 3 pi over 4. All right, so now that I have that, I need a tangent slope. How do I get my tangent slope? Derivative. What's the derivative of arc cotangent? Perfect. And then I just plug in -1. Y prime equals -1 over 1 plus -1 squared, -1/2. Yeah, but it doesn't. It's fine. All right. Next, I just write my tangent line. Y minus 3 pi over 4 parenthesis x. Y minus 3 pi over 4 equals parenthesis -1/2 parenthesis x plus 1 close. And there it is. That's my tangent. And if you plot it, which we just plotted it a little while ago for reasons, there it is. Cool, right? Cool. Here we go, guys. I want you to notice something. All right, let's do this one really quick together. What do you notice about this limit? This is the definition of what? This is the definition of a derivative. They want the derivative of arc sine evaluated at 1/4. So I go like this. The derivative of arc sine is 1 over the square root of 1 minus parenthesis 1/4 close it squared. Can we do that? Yes. And then let's see what we get. 1 over the square root 1 minus 1/4 squared is 1 over 16. And then that 1, I'm going to turn it into what over what? Not everyone at the same time. 16 over 16. What is 16 minus 1? Guys, 15. Square root of 15 over square root of 16. Laws of exponent. Square root of 15. Let me write it better. Square root of 15 over square root of 16. That's your laws of exponents. What's the square root of 16?
4.
So 1 over square root of 15 over 4. Keep, change, flip. That's 4 over square root of 15. They probably want you to rationalize it. It's as simplest form. I'll check to see if you can write 4 over square root of 15. But they probably want you to write it like this. So 4 square root of 15 over 15. So let me write that and see if it counts it correct. So what did I say? 4 SQRT 15 over 15. I push submit. And there it is. Oh, look, they also take it like this, guys. So let me see if I can show it again. Look, they also take it 4 divided by SQRT 15. It looks like they take it like this too. Yep, they take it like that too. So it doesn't matter how you put it. They'll take it both ways. 4 over square root of 15 or 4 square root of 15 over 15. Cool or not cool?